So now coming back here, voltage divider and current divider, what are they? They are simply techniques. Okay, by techniques it means that if you don't know this, and if the question didn't actually ask you to use the techniques, by using your Ohm's law, what else? KCL, and then you have your KVL, and you also know your resistors in series and also in parallel. I would say pretty much it is enough for you to answer the question. Okay, but techniques really do help. And later in chapter 4, we will expand the techniques and you will learn more methods, starting from chapter 3. Okay, now what is this voltage divider? So I put up a mental note, how to draw a brain. So I put up a mental note for you guys. Looks like a wheel. Alright, so these are the two mental notes that you have to remember when you want to use voltage divider or current divider. Okay, so for voltage divider, what is it? Okay, so voltage divider says that if you have a voltage source and it is connected in series with multiple resistors, 2 or more, you can use this voltage divider. Say you have 4, let me just call that Vs, R1, R2, R3, and R4. Okay, and by the current convention, current enters the positive terminal, and if it follows Vx, okay, just going to make, for argument's sake, that is Vy over there. So if I put here Vx, okay, so by current divider, Vx equal to its resistor, which is Rx, over total resistor, what is it? It's R1, R2, R3, R4, the one that is in that are in series with it. R1 plus R2 plus R3 plus R4. Let me, and then multiply by Vs. Okay. Now, how about if the question asks for Vy? It is still voltage source connected in series with the resistor. Okay, the only thing that you have to be careful is, okay, passive sign convention, current enters in this way. Alright, so Vy will be, negative its resistor over total resistor multiplied by the voltage source. Okay, just because that this one here, okay, this is given to you, the variable and the signs are given to you. Okay, so by passive sign convention, you know that current enters a positive terminal, hence it's negating. This variable Vy is negating, hence y it is negative. Alright, now take it in first. We will see more when we do the example. Now, how about current divider? When can you use the technique? So if you want to use the technique, it says that you must have a current source or current value. Later, you will see this again. And only 2 resistors connected in parallel. Only 2. I have to hide that. So if I have an IS over there, I said IS, but I wrote IX. So if I have an IS, and let me just call that R1 and R2. Say for example, I want I1 by current divider, I1 equal to opposite resistor, opposite is R2, over R1 plus R2 multiplied by the current source. If I want I2 instead, no, why not we do in the opposite direction? If I want I2 instead, it's given to you the variable in that sense. Okay, I2 is opposing the direction of IS. When current enters, current should leaves, right? Okay, it's opposing the direction of the current coming from the source. So I2 in that sense will be negative opposite resistor, which is R1 over R1 plus R2 multiplied by IS. Okay, so these are the basic rule. Okay, these are the basic rule on when you could actually use voltage divider and how for you to actually use the voltage or current divider. Now let's go to an example. So you have this example. As usual, elaborated circuits. I love elaborated circuits. And then the question says, by using current divider or by using voltage divider, solve for a certain variables. So why don't we go on the first one? Let us use current divider for this. So the question says, by using current divider, find Ix. So by using current divider, it already specified the techniques. So you have to use current divider. Okay, you need to find Ix. Now, first thing that you have to take note is, madam, there is no current source. This is voltage source. Okay, remember back when I said that you can actually get Is. Okay, remember when we in the last class, okay, I mentioned that you can actually get Is. Okay, what is it? So if you want to get Is, is Vs over R equivalent. Remember this? Where R equivalent is here. You have to find the whole resistor there. Okay. So you need to use whatever knowledge you have learned. Okay, resistors in series parallel and get me R equivalent for you to get Is. So once you get your Is, you know that you can get the current here, and you have to get only two resistors connected in parallel. So basically at the back of your head, so one, you have to do that. The other is you need to do this. You need to establish a circuit of only two resistors connected in parallel. So this one here is Is. Okay, you know that you can ignore 1 ohm and 1 ohm. Okay, but because it doesn't enter the two parallel conditions. Okay, so you know that this is 2x and 2 ohm, and this one is Ix. You need to find Ix. You need to find what is this Rx. So when you are doing current divider, you need to be able to actually show the manipulations. Okay, how you get the R equivalent, for example, and how you manipulate the resistor so that you get the condition in which you can use the techniques. Okay, now look at the circuit. Okay, take it as practice. 3 ohm and 3 ohm, series or parallel. This bit here, this 3 and 3. Yep, they are in series, only one point of connection. So if I have to resketch the circuit, it will look like this. 3 ohm, 3 ohm, right? Okay, so that is 3 plus 3. That is a 6, that is a 3, and then there's a 2. And then there's a 2, and then another 2. Am I right? So I have to make it small. You may enlarge it later when you're watching this. And then that's 2. Okay, so you need to actually simplify this bit. Okay, you need to simplify this bit. I highlighted it. Okay, so what is it? What is it? So that Rx, this is basically once you simplify it become Rx. So what is Rx? I can hear Shafaq's voice already. You can also hear, I think, who always, I cannot buy because I didn't see your name. Okay, and then now it will be 3 plus 3 in parallel with, so it will be 6 in parallel with 3, and then the whole thing just have to be, yep, they are in series. Very good. Okay, you plug into your calculator and you will get that one 2 plus 4 gives you 6 ohm. Okay, so your Rx here is 6 ohm. Okay. But now you need to get R equivalent, isn't it? In order for you to get Is. So what is R equivalent? Where R equivalent equals to what? Yep. In this case, when you want to find R equivalent, remember you have to do at this point. It will be 1. You have, yeah, you can do 6. Yeah, you can start with that. Very good. Okay, you can do 6 in parallel with 2. Yeah, trust me, I can actually hear your voice when I'm doing this. So 6 is in parallel with 2. Very good. Okay, 6 is in parallel with 2. And then you add that one and that one. Superb. Very good. Oh, I forgot the one. Okay, you plug into your calculator. You will be getting a value of, let me see, 3.50. Therefore, what is your IS? IS equals to VS 10 over R equivalent of 3.5. You will get your IS of 2.86. Don't forget your unit ampere. Always remember your unit. Alright, so now we have the circuit basically. Alright, so now you have a current entered this bit of 2.86, and then you have only 2 resistors connected in parallel. Okay, so therefore, okay, by current divider, Ix equals to opposite resistor is 6 over total resistor, not 1. Okay, you do not put 1 and 1 because it is not included in the parallel. Okay, it is just 6 plus 2 multiplied by the current source that comes into the parallel section, which is 2.86. Plug into your calculator, you will be getting multiplied by 6 divided by 8. Alright, 2.14. Trust me when I say I did this one. What's the unit? Yep, you are right. It is 2.14 ampere. Okay. Now, say now we are doing. I put another page actually. I was thinking that I should use this for the class. Anyway, now second example. Now by using voltage divider, find Vy. Okay. So we already did current divider. Now let's do voltage divider. When can you use voltage divider technique again? Yep, the rule says you must only have the voltage source connected in series. So it is in series with 1, it is in series with 1, but this whole lot here, this is not in series, this is a combination of something. So you need to transform this to make it in series. Okay, so you know at the back of your head, you need to actually produce a circuit of a voltage source that has only 3 resistors. Let me just call that Ry. Okay, although here is Vy, using that variable over there, that's 1 ohm, 1 ohm, and that's 10 volt. So at the back of your head, you know that you need to change this, you need to manipulate this whole bit, okay, to change it to Ry. Okay, so let's do it. So what is Ry? You have done it before just now. So yeah, you can actually just look at the previous slides, but I want you to practice. So Ry will be, you go from the furthest end, right? Okay, so you look, they are in series, so 3 plus 3 in parallel with this 3, and then they are in series with 2 and 2, and then the whole lot is in parallel with these 2. Okay. And then after you plug into your calculator, you will also get 1.5 ohm as the previous question. Okay. So now your Ry is 1.5 ohm. So if I ask what is Vy then? So remember, now you have to look at the passive sign convention. the current is flowing that way, so supposedly it is this way. So Vy variable, the one that is given to you, okay, positive, negative, so therefore Vy by voltage divider equals to its resistor, alhamdulillah, yeah, is 1 over total resistor is 1 plus 1.5 plus 1, 1 plus 1.5 plus 1 multiplied by the voltage source. In this case it's 10, isn't it? So don't forget negative because it is negating. So the answer is, let me just put it back, 1 plus 1.5, that is 3.5 multiplied by 10. So you put into your calculator 1 divided by 3.5 times 10. Okay, give you negative 2.86. What's the unit? Super. Alright, brilliant. So with that, you actually have completed doing voltage divider technique, using voltage divider technique to solve for Vy. And you also have actually used current divider to find Ix. Alright, thank you.